Alright, so still on the past question, this is question 2b. Question 2b, they're asking us to find the dy dx given that y is equal to root sine root x. Root sine root x. So solution of this problem, we were given y to be equal to root of sine root x. Alright, root of sine root x, which is also the same thing as sine x to the power 1 over 2 all multiplied by 1 over 2. So this and this is the same thing, right? So root is half, root here is also half. So we've just succeeded in deducing this expression to this, so we'll be making use of this. So y is equal to sine x to the power 1 over 2 or x to the power 1 over 2. Right, so this is what we'll be making use of. Right, we're making use of this. Right, so we are going to be assigning some alphabets to this expression in order for us to easily solve them. So we can, from this expression, we can say that let u, right, so let u equal to x raised to the power 1 over 2, right, x raised to the power 1 over 2 here, such that right, so since I have let u to be equal to x raised to the power 1 over 2, I can assign sine to v, so meaning that I can say let v to be equal to sine of this. So this will be my v. So because I said u to be equal to d, so anywhere I see this, I'll put u there. So it will be sine u here. Right. So the idea there is just very simple. Let u here equal to this expression, and let my v equal to this whole expression. Right, equal to this whole expression, because I know my u to be this. So since I say let v equal to this whole expression, and I already know my u to be equal to x raised to the power this, that's x raised to the power 1 over 2, which is this. So I can just replace it here as what? U. So because of that, I can now rewrite this expression by saying that y is now equal to, because I say v is equal to this, which is this here, I can now say y is equal to what? V raised to the power what? 1 over 2. V raised to the power 1 over 2. Right, so I can look for dy dx, dy dv, I can look for du dx, and I can also look for dv du. Right, those are just the cheat there. So from this point, let's start from here. Look for du dx. So du dx here will give me, from here I will just have to pull off this power, bring it to the front, then subtract it by 1. I'll have 1 over 2 x raised to the power 1 over 2 minus 1, which is going to give me 1 over 2 x raised to the power, this will be 2 times 2 here, and 2 times 1 here will give me this will be LCM here is 2, then 2 times this will give me, here will be 1, 2 times this will give me 2, then when I subtract, I'm going to be having minus 1 over 2, so it means that here will be minus 1 over 2. So the differential of du dx, differential of this is 1 over x to the power minus 1 over 2. Alright, so that is du ds. So this can also be written as 1 over 2 times 1 over x raised to the power 1 over 2. Alright, so this is what it means, which is also the same thing as having du dx to be equal to 1 times 1 gives 1 over 2. Right, so this is x raised to the power halves, which is also the same thing as root x. So this is du dx here. So let's also do for dv du. Right, so dv du will be equal to, so if we differentiate this, we'll be having cos u. So that's what we'll be having, cos u, which is equal to cos, and we know our u. What's our u? X raised to power 1 over 2. That is x raised to power 1 over 2, which is equal to cos root x. So my dv du is cos root x. So we'll do dy dv. So dy dv will be equal to, we'll do the same thing here. We'll have 1 over 2v raised to power minus 1 over 2. So that's the differential of this. I'll bring out half, then reduce it by 1, just the same thing we did here. So we'll be having equal to 1 over 2 times, right, 1 over v raised to power 1 over 2, which is equal to 1 over 2 root v. And what's our v? We know our v to be this. So my dy dv will be equal to 1 over 2 root, right? So this is sine u. That's our v. Our v is sine u from here. Sine u v. So we'll substitute it here. That's this point. We'll have sine u. And we already know our u to be this. So still substitute again to have 1 over 2 root sine. Right, so what's u? U is this, x raised to power 1 over 2. X raised to power 1 over 2, which is also the same thing as having 1 over 2 root sine root x. Right, so this is what we have. Alright, so we've succeeded in looking for differentials of u, y, and then v. Then we'll be applying chain rule. This is what we just applied, chain rule. So from chain rule formula, from chain rule formula, we'll have that dy over dx will be equal to, we have dy dv times dv over du, then times du over dx. Right, so we've already known the value for dy dv du, and then du dx. So we just go for that to substitute the values to this expression and then get our answers. Right, so my dy dx here, my dy dx will be equal to my dy dv, which is this. My dy dv is 1 over 2 root sine root x. That is 1 over 2 root sine root x here, then multiplied by dv du. My dv du, which is this is dv du. This is dv du here, which is cos root x, dv du cos root x, then times du dx, times du dx. My du dx here is 1 over 2 root 1 over 2 root x. This is 1 over 2 root x here. Right, so that's what we have. So we'll be joining all this together now to be obtaining dy dx to be equal to, this is 1 times this, 1 times cos root x times 1 will give cos root x all over, I have 2 root sine root x times 2 root x. I'm going to be having this is 2 times 2, which is going to be giving me 4. I have root x, then I have another root sine root x here. So it means that my dy dx is equal to this. which is the answer to that problem.